Today we are going to discuss about part 2.2 of Java data types, variables, primitive types and casting. So we have already discussed about Java identifiers and naming convention, and YouTube video also has been uploaded. So today mostly variables, primitive types and casting. As you know, Java working with Java data types is approximately 15 to 20% of questions come from this topic. Is quite important, so you have to learn properly. Okay. So what is a variable? A variable is simply a named memory location that stores data. So in memory, there is a location which stores data and its name is called a variable. So think of variable, it's like a hotel room number. The variable address, say room 302, and data will be the guest's name. Guest, today Alice is staying in room number 302. Update tomorrow, Alice checks out and Bob checks in. So the key point, the variable stays the same, but the person inside the room can change, right? So data type is string in this case. So what we discussed, right? So apart from that, if you see this example of int age is equal to 25. So in this case, int is the type, age is the name, and 25 is the value. A type is what kind of data it holds, right? So in this case, it's holds this particular variable holds int. And what's the name? A valid identifier, the name of the variable, and the value assigned before use for local variables. Obviously, for instance, in static, those are, as we discussed already, those are by default. So declaration versus initialization. So what is declaration? Declaration is creating the variable, no value yet. So if we declare int x, then double price or boolean flag, we have not given them any value, but they have been declared. The variable has been created, right? So declaration when you create the variable, you tell Java the type and name like int x, that's a declaration. The variable is existing now, but it has no value yet. It's empty box with a label, right? No, it doesn't contain any value. And initialization is when you assign a value to the variable x is equal to 10. Now the box has something inside it. You can also combine both in one line, that is int a is equal to 5, and declaration and initialization together, right? So here also we have shown some examples here. Price 99.99, flag true. So all these are, you are initializing, right? So you are assigning a value. After declaration, you are assigning a value, and you can combine them together, like char grade is equal to, within quotes, say. So OCA rule is declaration doesn't give a value to the local variables. You must initialize them before use. Like we have discussed what's a local variable, what is an instance variable, was a static variable earlier. So as we know that instance and static variables get some default values, but local variables, those are variables, those are declared within a function, even within main function. So those must be initialized before use, right? That we have already discussed, otherwise you will get a compiler error. So multiple declarations on one line. This is very tricky, so you have to understand this thoroughly, right? So you can have int a, b, c, those all three variables, it will compile fine because they are all have return types same, right? And then int a is equal to 1, b is equal to 2, that's also declared and initialized. But say you have written int a, b equal to 5. In this case, what happens is for local variables, only b is initialized, right? A is not. So that we have to see that. So if you want to use a after that, it will not work. A is not being initialized here with 5, only b is, right? So that's a trap. Another trap is like we have shown it here, right? So you have declared int a is equal to b is equal int b, b is equal to 5, but you are trying to use system.out.println a, right? So you are trying to use a here, and a is not initialized yet, right? So it will lead to compilation error, but this will work. It will print 5. And also another thing is that you cannot mix types, right? In the multiple declarations, you cannot have int a, double b. Here it will lead to compile error. So different types, right? So you cannot mix those things, int a, as to. So you have to write them as separate statements. Then we have 8 primitive data types, right? So variable, like we discussed, a variable has a return type. So let's discuss what kind of data type or return type there are, right? In this case, so we have byte, short, int, long, float, double, char, and boolean. So byte is the you can say it's 8-bit, short is 16-bit, int is 32-bit, long is 64-bit, float is 32-bit, double 64-bit, char 16-bit, and boolean is JVM dependent. So they all have some range, right? So for range, and for byte it's minus 128 to 127 plus 127, and short is 16 bits, holds about minus 3200 1000 to plus 32,000, right? int is 32 bits and is minus 2.1 billion to 2.1 billion or approximately, and length is 64 bits, and it holds an extremely large number. And then we have char, we have float, basically decimal numbers. You have two things. Float is 32 bits with about 7 digits of precision. We're going to discuss that in detail in the next slides. So what is a precision and how does it matter, right? And double is 64 bits with about 15 digits of precision. Then you have char, 16 bits, stores a single character using Unicode, and the range is 0 to 65,535. And there's something important here. The char is the only unsigned primitive data type in Java. It cannot hold negative values, that we have to remember. And finally, boolean, it holds only true or false. The JVM decides its actual size internally. For the exam, you absolutely need to memorize the byte range minus 128 to plus 127. This comes up in overflow questions. And you also need to know that char is unsigned and that boolean is completely separate from numeric types. You cannot cast between boolean or any other. That's absolutely important to know, that you cannot just put a casting that is within brackets int to a boolean variable. It will work, it will not work. A memory trick for the order, we have to remember that is the memory trick, right? Byte to short, to int, to long, to float, and double, right? Small to large, we have to remember that. And they all have default values, like if they are static or instance, right? So byte has 0, short is 0, int is 0, long is 0, l, right? It has a suffix l. And then float is 0.0f, and double is 0.02, and char within quotes /u, then 4 zeros, and boolean's default value is false. These values, default values, are very important from the exam perspective. They were tested there. Actually, you have to remember all this, that for boolean it's false, for char it's within quotes u000, 4 zeros, and then other things mostly are zeros. Only you have to remember that long is 0l, 0.0. These two are 0.0, f and d, right? Float and double. We have to remember that. Next is precision. So what is that, right? So what does it mean? What does 7 digits precision actually mean for float? It means that float can actually store about 7 significant digits. After that, it starts losing accuracy. Watch this. So you have, say, float 1 2 3 4 5 6 7 8 9 dot 1 2 3 4 5 6 7 8 9 f. And then you do a println, right? System.out.println of that variable f. And what does it print? It prints 1 2 3 4 5 6 7 8 9, then 2 e8. So you gave it 18 digits, but float only kept about 7 accurately, right? So so you gave it how many here? 9 and 9, 18 digits, but how many it is accurately printing? 7 accurately, right? Printed accurately. After that, the rest becomes garbage basically. 792 here, right? And it's not rounding also, it's just running out of space to store the precision. Now double has 15 digits of precision, so double d, if you put the same number there, so it will, and if you do a println here, it will print properly up to 15 digits, right? 7 up to this it will print 1 2 3 4 5 6 7, and then 8 9 10 whatever, and up to 15 digits it will print accurately. So it is much better, but still not perfect. The 79 at the end should be 789, right? It should not be 779, it should be 789. So you see, at least double is having more precision. So that is why Java makes double the default for decimal numbers. It's more precise. When you write 3.14 in your code, Java treats it as a double, not a float. You have to remember that for every decimal number you see in Java, right, it's a double. It's not a float. So it's a 3.14 if you see, it's a double, not a float. That's why only float, why float f is equal to 3.4 if you write, it will give you compilation error, because if you just like that cannot assign a double number to a float variable, right? So Java says no, you might lose precision. So what you have to do is that you have to either write float f is equal to 3.14 f. That way you are telling Java, okay, I know, I accept the lower precision, and so it's a floating value, right? Float value. So when does it matter in real life? Money calculations, if you are calculating, say, with money with tax and discounts using float, you may get lesser, right? You may get 13, say if you are calculating 1000, you may get 999.9999, etc. That's why banking software never uses float. They always use big decimal, but that's a separate topic. But for the OCA exam, just remember float gives you 7 digits, double gives you 15 digits, it's more precise, and in Java, double is the default. So Java data types and literal suffixes. So this slide is responsible for most lost marks on the OCA exam than almost any other topic. Literal suffixes, they are simple, but the exam exploits them ruthlessly. So here's the rule: when you write a whole number like 100 in your code, Java treats it as an int by default, not a byte, not a long, always int. When you write a decimal number like 3.14, Java treats it as a double by default, not a float, always a double. So what happens when you are writing long x is equal to 1, then 10 zeros, right? So that number is too big for an int, and Java is trying to treat it as a int first, but that leads to compilation error because int range is not that much, right? So you need to add the letter L at the end. So you have to write long x, then 1, 10 zeros, L. That L tells the compiler, don't treat this as an int, it's a long literal. Same problem with float. Float f is equal to 3.14 if you use, it will be compiler error. But if you put an f there at the end, f suffix and tells compiler it's a float. So that's what we are talking about, suffixes, right? L, F, all this. So rules: any whole number literal is an int by default. Any decimal literal is double by default. Need L or capital L or small l for long. Prefer uppercase L. Lowercase l looks like 1 sometimes. And need A for F for float. One more thing, Java allows underscores in numeric literals for readability. int million is equal to 1_000_000. That's perfectly valid and equals 1 million. So that's allowed. The underscores are ignored by the compiler. But that underscore cannot be at the start, at the end, or next to the decimal point. That's a very important point. You have to remember that. You can write like 1_0000000 for 1 million, that's fine. But you cannot start a number value with an underscore, or underscore cannot be at the end. And also if you have a decimal value, and also not before and after of the decimal point. So that's about literal suffixes. So why do you put it? Because so that the compiler doesn't reject it, understands that's a float value or a long value. And then default values versus local variables.